Hello and welcome to another Physical Sciences 3 lecture. Today we are looking at vertical motion, which is another example of the equations of motion that we saw before if it's just falling in a straight line. So if frictional forces such as air resistance are ignored, vertical motion is an example of motion in a straight line under constant acceleration. Okay, and that constant acceleration is the acceleration due to gravity, which is equal to 9.81 meters per second squared downwards towards the Earth. In such cases, we can analyze the motion using the same equations and steps shown previously. However, there are some important points listed below to help you with understanding vertical motion. So an object is said to be in free fall if the force due to gravity is the only force acting on the object. Unless otherwise stated, you should ignore frictional forces and air resistance. Okay. And we just said the acceleration of any object in free fall is given by gravity. G equals 9.81 meters per second squared. A couple more points here. So vertical motion is said to be symmetrical. So that means that the upward motion has the same speed, acceleration, and characteristics as the downward motion, but in the opposite direction. Okay. An object at the top of its flight has a velocity of 0. So this is at its max height. So often we'll have to work out how high it is, and at max height the velocity is 0. And similarly, an object dropped has an initial velocity. So remember, initial velocity is u of 0, u equal to 0. Okay, if it's dropped. Good. Okay, there we go. So we've got some examples. All right, good. Got some examples here. So a person drops from a bridge 25 meters above the water. So what was the person's initial velocity? So the key one here is drops. That means that u equals 0. So the initial velocity is u equal to 0. And meters per second, we don't really need units because it's 0, but meters per second. How long will it take them to hit the water? So this is where we go to our SUVAT, S-U-V-A-T, just like we did before. And I might move my cursor away. There we go. SUVAT, so U, V, A, and T. And how long will it take them to hit the water? So what do we know? We know that the bridge is 25 meters high, so that means their displacement, let's just say that up is positive. So we're going to, if we say up is positive, then we're going to have S is equal to negative 25, U is equal to 0, V, we don't know what V is, A is equal to negative 9.81 meters per second squared. Because it's down, we have that negative, so that's the key thing there. And how long, we don't know the time. Okay, so we have what we do know here. How long will it take them to hit the water? Okay, so remember with our formula sheet, we have to figure out which one of the equations we're going to use. So we have S, U, A, and we're looking for T. So we can use this one here, S equals UT plus half AT squared. And we can substitute in our values of negative 25 equals 0. So U is equal to 0, so that means that first term goes to 0, plus a half times negative 8.1 meters per second squared, and we have T squared here. Okay, so if we rearrange this equation, we will get T squared is equal to negative 25 times 2, so that's getting rid of this half term, and then divided by negative 9.81. So those negatives will cancel, so we'll end up getting T is equal to the square root of 50, so that's 25 times 2, divided by 9.81, and we need to put that into our calculator. So get our calculator up and go to the main. So if you're following along with this calculator, we've got 50 divided by 9.81, and that is equal to 2.25, oops, 2 point, let me just get that up again. So it's going to be 2.2, we'll go to 3 significant figures, so 2.26. 2.26 seconds. 2.26 seconds. Okay. What was their impact velocity? Okay, so now we know that we have time, it's 2.2 seconds. We can have V is equal to U plus AT. So we have equal to 0 plus a negative 9.81 times by 2.26. And that's equal to, so let's get our calculator out. So minus 9.81 times by 2.26. That's equal to negative 22.1. I didn't see the rounding up there. We'll do 2. And that's going to meters per second squared. Meters per second, sorry, just meters per second. And because that's a negative, so that's in the up direction, it's going to be negative, which is equal to positive 22.2 meters per second down. Now, this is a good example of why we often say that our direction, our positive direction, is downwards, because if we chose our positive direction as downwards, then this S term here would have been a positive 25. The acceleration due to gravity would have also been positive, so we would have just got a positive answer here straight away for our velocity, our final velocity. But they are equivalent, so you just have to keep track of your directions. All right, we'll do the next example next time.